In this video, I'll be covering problems 1 and 2 from your test review. And this is actually your fourth test. For number 1, it says Rebecca and Cameron are arguing over which one correctly simplified the given expression. Determine if Rebecca or Cameron is correct and explain what the other did incorrectly by looking at their work. So it appears here that Cameron, recognizing that you're taking the cube root of a fraction, separated the numerator and denominator and then simplified those individually. So she has the cube root of 2 times 2 times 2 with 5 x's, all over the cube root of 27, being a perfect cube, is 3. So then she recognized that you could form a group of 3 2's and 3 x's, so that came out. And then she's got 2x times the square root of x squared over 3. Well, remember here we started with cube root, but it looks like Cameron did not include the cube root right here. But let's go ahead and compare that to Rebecca's work. For Rebecca's work, she rewrote, she simplified inside the radical, or she went ahead and wrote the prime factorization for the numerator and denominator. So she's got 2 cubed, x cubed, and x squared. X cubed because she's got a group of 3 of those. So, and then she's got 3 3's. So she has 2x cubed, or 2x over 3 all cubed, but then she takes that out as 2x cubed here in your final answer. An x squared is left, so that's left. What she did was, because this was a product, she separated it into the cube root of the quantity 2x over 3 all cubed times the cube root of x squared, which is a correct step. So she took, because she's taking the cube root, there were 3 of those, so she brought that out as 2x over 3. She does have the cube root of x squared. If you compare their answers and see how they're alike or different, they're pretty much the same. It's just that instead of the 2x over 3 being separated, she's got them all together as the numerator. It looks like the only thing Cameron here is missing is the cube. So I would state that both have correct work, but Cameron's answer is missing the index. And that's it, okay? So this might look a little more confusing, but Rebecca's train of thought is correct. It is the correct work. So just make sure, and hopefully that'll remind you to always follow through and make sure that when you do your work that you don't leave out the index in your answer. Okay? Next, for number 2, you're asked to simplify these. So I'm going to rewrite them on paper here. So as I explain these, I'll probably be very detailed and deliberate, but you don't necessarily have to be. I just want to make sure that the support is there for all students who might not understand how to get that answer. So remember to simplify radicals. Oh, by the way, that's cube root. Very, very important. Tells us the size of our groups that we're going to find are of size 3. We want to find the prime factorization for our radicand. So this is really the cube root of 3 times 5 times 5, and then 9 x's, eight y's, and 1 z. So because of our indexes being 3, we want to make sure that we look for 3 of the same factors. So we have 1, 2, 3 groups of x's, so x cubed is going to come out. 2 groups of y's, so y squared will come out. And there's nothing left, not even with our numbers. So we have to make sure, and please make this part of your radical wide enough so that your index clearly fits in and does not get confused as an exponent. It would be x cubed y squared, cube roots of 75, because all you can do is multiply those together. We have no x's. We do have 2 y's and 1 z. Okay? And that's all you can do to simplify that one. For B, to add and subtract radicals, you do need to have like terms, which means they have to have the same radicand. So to determine what those simplified radicands would be, we are going to need to break this down and simplify each. So if that's the square root of 2 times 2 times 3, we can pull a 2 out. That'd be 2 times 24, which is 2 times 12, which is 2 times 6, which is 2 times 3. So if that's the square root of 2 times 2 times 2 times 2 times 3, I can pull this 2 out and another 2. So that would be 2 times 2 square roots of 3, or 4 square roots of 3. Now some of you all may be able to do this in a lot fewer steps. That's perfectly fine. I'm going to make sure that we don't have any terms missing, or at least our signs in our final answer as well. So 27 breaks down to 3 and 9, which is 3 and 3. So if we have the square root of 3 times 3 times 3, we'll pull 1 3 out, and that will give us 3 square roots of 3. So what we're looking at this point is 2 square roots of 3 plus 4 square roots of 3 minus 3 square roots of 3. In this case, they are all like terms because the radicands are all 3, which means we simply combine the 2 and add 4 and subtract 3. So 2 plus 4 is 6. 6 minus 3 is 3. So we're going to have 3 square roots of 3. Now, for all of these, please use your calculator and check your answer. The square root of 12 plus the square root of 48 minus the square root of 27, and hit enter, and then type in your answer, 3 square roots of 3, and it should match. For problem C, we're multiplying two binomials. Sorry. So we're going to multiply these together. You can use the box if you like, or just remember to double distribute. Your rule, however, is that if you have numbers, of course, you can multiply those together. So 3 times 2 would be 6. And then when you multiply a number without a radical times one with a radical, the most you can do is put them side by side. So that would be 3 square roots of 6. When you distribute here, that would be 2 square roots of 7. And here, positive square root of 42. Now remember, the square root of 42, we already know its factors are 6 and 7, none of which will give us pairs, so we can't simplify that any further. We do not have any other like terms because we have no radicands that are the same and no integers that we can combine, so this is our final answer. Again, I'm going to check in the calculator to make sure we're thorough. 3 plus the square root of 7 times 2 plus the square root of 6. Oops. You need to hit the right arrow to get out from under the radical. And then our answer, 6 plus 3 square roots of 6 plus 2 square roots of 7 plus the square root of 42. And it matches. Next, for D, 3 square roots of 5 divided by the square root of 7. We have to rationalize this, meaning we want to turn this irrational number, the square root of 7, into a rational number. The reason why we say it's irrational is because when we type in the square root of 7, we get a long string of numbers after a decimal that do not have a pattern and they do not terminate. So what we want to do is rationalize. To do that, we can get rid of this radical by multiplying both the top and the bottom by the square root of 7. Now remember, this just really equals 1. Any number divided by itself is equal to 1. So we're not changing the value, we're changing the form to make it our denominator rational. So up top, when we multiply, we get 3 square roots of 35. And then on the bottom, the square root of 7 times the square root of 7 is the square root of 49, which happens to be 7. Now, if you could reduce these numbers on the outside, you would. If you could reduce your radical, you should as well. but we know that 35 is made up of 5 times 7, both of which are prime, so we are not going to be able to pull out any pairs, so that should be our answer. Now when we check these, we want to make sure that we put, actually you don't have to in this case. Let's think about parentheses. So 3 square roots of 5 divided by the square root of 7, where's our original problem, hit enter, and then type in 3 square roots of 35 divided by 7 and hit enter, and they are equivalent, so that means our answer is right. Uh-oh. Tore my paper. All right. So next for E. All right, again, we have a radical in the denominator, so we want to simplify anything that we can first and then rationalize. So recognize that this is 5 times 5, A times A, and you've got some groups here, right? So if we reduce this numerator, we get 5A square roots of B. Well, again, we don't want to leave a radical in the denominator, so we want to rationalize by multiplying the top and bottom by the square root of B. Now, why do we do that? Because that would give us 5A square roots of B squared, which is B times B, which now allows us to take a B and pull it out. So that makes our denominator 5AB. Now on top, when we multiply these together, it's simply a number and a radical, so there's really nothing we can do except leave it. And that would be our final answer. Now, while you can't type 2 different variables in the calculator, you can just make sure that everything is equivalent. So if I type in -2 divided by the square root of 25, we should recognize that as 5 anyway. We get -0.4. And if I just type in my number part here, -2 divided by 5 rather, is -0.4. So those match up. So the number part at least is equivalent. Just make sure, I would recommend to simplify first. Then you only have to rationalize with a small amount and not have to reduce. Be careful though, the B does not cancel with the B in the radical. And lastly for F, in this one here, we want to rationalize by using the conjugate. So that means we change this minus sign to, or excuse me, this plus sign to a minus and use 6 minus 5 square roots of 6. Whatever we use on the bottom, we also use on the top. And now we're going to have to multiply this out. So some students find it easy to use the box, or you can just double distribute. I'm going to show you the box just because it may help some of you. But either way, whether you just distribute or use this method, you should get the same product. So 4 times 6 is 24. 6 times -8 is -48. Square roots of 3. And here we get -5 times 4 we are allowed to multiply, so -20 square roots of 6. And then lastly, -5 square roots of 18. Now, if anything can be simplified, we should. The square root of 18 is able to be broken down into the square root of 9 times 2, of which 3 and 3 are factors and can be pulled out. So this 3 will get multiplied with this 5, and what's left is the square root of 2. So -15 square roots of 2 is really what we have in this last box. If you're not sure if you did that math correctly, you could always type in -5 square root of 18 and then -15 square root of 2 just to make sure you simplified it correctly, and that should be equivalent. So that means our numerator, when we distribute and simplify, should be 24. We do not have any like terms. Minus 48 square roots of 3, minus 20 square roots of 6, minus 15 square roots of 2. Now, if you have these terms in a different order, that is perfectly fine. So don't worry about that. Next, if I multiply 6 minus 5 square roots of 6 by 6 plus 5 square roots of 6, again using my box, 6 times 6 is 36, minus 30 square root of 6, but this time we get positive 30 square root of 6, and then minus 25 square root of 36. Now what should happen is these middle terms should cancel out, so you don't really have to do all these steps. I've showed you the shortcut before. So this is negative 25 times positive 6, which is negative 150. So notice at this point we have 36 minus 150. 36 minus 150, oops, is negative 114. Now, one thing I've also shown you is that you can reduce. So that means if 24 and 48 and 20 and 15 and this number all have a common factor, then you could reduce. So that it looks like they're all even with the exception of 15. So that means unless they're divisible by 5 or 3, there's nothing we can do to reduce. However, our denominator is negative. If your denominator ever ends up negative, then you'll want to change all of your signs. So our final answer should be negative 24 plus 48 square roots of 3 plus 20 square roots of 6 plus 15 square roots of 2 all over 114. So as you can see, because this requires so much work, this is going to be like a 4-point problem. It's going to be weighted quite a substantial amount higher than a problem like E. Okay, a lot more work involved. And you may not need to do these boxes, but it does require a little more precision and simplifying there at the end. Okay, so that concludes problems 1 and 2. The next video will cover problem 3.